.NET 8 with Scott Hunter.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm empowering software delivery for business-critical software projects. And a quick announcement, my architect forums are going strong. It's a great session once a month. Signups for the next session are up. And if you lead a software team and you're looking to collaborate with some of your peers across the industry, then you can just go ahead and sign up at the link in the show notes. It's completely free and it's a fun time. And also for those of you looking for Programming with Palermo, my video podcast, you can just search for it in any of the podcast directories and you'll be able to find it. Now, my returning guest today on the show is none other than Scott Hunter. He's the Vice President of Product for Azure Developer Experience, and he builds all of the .NET tools for Azure and all the things .NET, and he has been in the mix and leading things in the developer division for a long time. Scott, welcome back to the show. How are you, sir?
Thanks for having me back, Jeffrey. I'm super excited to be here and super excited to talk about .NET 8.
Absolutely, absolutely. Now, our developer world keeps on growing and growing and growing, and so I think most of the listeners of the show saw your episode last year where we were talking about the .NET strategy as .NET 7 was coming out. But for the newer developers who are kind of listening, if we rewind just a little bit, what are the big memorable things in Microsoft in your long time there? Just what are the big things that stand out if you just do a little quick rewind?
I think the big things that step out. So for folks that don't know, I've been working at Microsoft since 2007. So I joined the ASP.NET team back in 2007, along with a bunch of other folks you might know, people like David Fowler, Scott Hanselman, Damian Edwards, Glenn Condron, or all Phil Hack, I should say as well.
Yeah,
we're all part of some of those early ASP.NET days. If I think of my most memorable things in my history at Microsoft, would be number one is in 2008 we released MVC 1.0 for ASP.NET, and that was because Ruby on Rails had just shown this new MVC pattern was a popular thing. But more importantly, MVC was the beginning of some of the open source bits that we had. So we shipped it as, it wasn't proper open source yet, but it was the beginnings of, it had an MSPL license, but it was the beginning of doing some open source stuff. I would follow that with 2012. We properly open sourced all of ASP.NET, and we started taking contributions on it. So that was a big highlight. But really, the thing that really starts mattering a lot to us is in 2013, we started asking ourselves, wow, this Linux thing is really important for web applications, and open source is a big thing. And so it was where the notions of what we now would call, .NET 7 came from. This is the ASP.NET Core revolution, where we kind of rebooted .NET. We kind of said, hey, the ecosystem has moved to a new place. We need to have the right product. And so we had a fully open source stack that runs on Windows, Mac, and Linux, runs on x86, x64, ARM32, ARM64, across a ton of operating systems. So to me, that 2013 was the beginning of a turning point of rebooting .NET, which we shipped in 2016 as a GA. And then I would say, if you go back and look, after we shipped .NET Core 3.1, we kind of dropped the core name and just shipped .NET 5. And so that was another milestone. And even what I do today is a milestone too. So 2 years ago, or a little bit over 2 years ago, part of that journey, I was not always in DevDiv. When Scott Guthrie moved to Azure in 2010-ish, or anything in DevDiv that was web related went to Azure. And so I spent a couple of years in Azure. We actually, the beginning of ASP.NET Core started in Azure, actually. And we worked on a bunch of tech, like app service, a great way to host your applications, Azure Functions. And what was really cool is 2 years ago, all of those developer-facing Azure services moved to DevDiv as well. And so to me, it kind of put DevDiv back together. DevDiv was all together like that in all the way to 2009, and then it split apart, and it gets kind of come back together. And I work on all of those Azure services. My team builds the tools for Azure. We build the SDKs for Azure as well. And so, but biggest milestone for me is going to be just that reboot of .NET. And we have over 6 million developers in .NET today, and I don't think we'd have those if we hadn't done that reboot. And we're about to do another kind of not a reboot, but there's a .NET 8 is going to not ship with, but have a preview of something what we call .NET Aspire, which you and I can talk about later today as well. And that's exciting because I think that's the next evolution of the ASP.NET technology.
Yeah, a lot. And actually just a few days ago, last week, .NET Conf, just a massive number of announcements. Again, you guys keep busy. So, hot off the heels of all the announcements at .NET Conf, and then of course, looking forward to Microsoft Ignite. What are the highlights? Like, there's so much content out there, but what should developers really focus on? What are the themes? Now, there's tons of stuff, but are the things that are, sea changes that are like, okay, don't miss these because these really do. These are the difference that make the difference.
I have 3 focuses on .NET. Well, maybe 4. I'll talk about 4. Let's talk about 4 things today that I think that are kind of important in the .NET ecosystem. And maybe we'll save Aspire till the end, and we'll start with some of the other ones.
Okay.
So C# 12 is something that we just shipped as part of .NET 8, and it's got a variety of features. It's got 2 features that really make me excited. Number one of these is something called primary constructors. And so I'll give you the scenario. You're a .NET developer, and what do you typically do? Well, I'm going to add a property called X. I'm going to have a property called Y. I'll have a constructor that takes an int X and int Y, and all it does is assigns the X and the Y to the properties.
Right.
And we've all written this a million times. A primary constructor means I don't actually put the properties there at all. I can basically, I put the properties there, and I can say, I can write the constructor now as part of the class, which means I don't have to create some of the temp variables in some cases. But let me really make this make a lot of sense. Dependency injection. So, an ASP.NET Core application, typically you're going to use dependency injection to put a database connection into the page you're working on. You might put a logger into the page you're working on. So what do you end up doing? You end up having a constructor that takes the logger and the database as parameters. You create a temp variable to store the logger in, a temp variable to store your DB context in, and your constructor just puts those things in. With a primary constructor, you don't need to write the temp variables at all. All you do is have the constructor take the logger and the DB context, and then you can access them in all the members inside of the class. And so it gets rid of like 6 lines of boilerplate in every single ASP.NET Core web page.
Yeah. Reminds me a little bit of the record syntax.
It is very similar to a record thing. It's just we now apply it to classes as well.
Yeah. And every class has that. Every single data transfer object. I mean, just so many. It's everywhere.
If you do file new Razor pages, every single page will have a constructor that takes a logger. It'll have a temp variable for the logger. That all just goes away. It's one of those things that, over the years of working in C#, why do I have using system at the top of every page? Right. We got rid of that. Why do I have, a class program? We got rid of that. It literally is, we look at the code that you're writing, and we're asking ourselves, why is that same duplicated code in every single file? It makes no sense. And so with global usings, which we did a couple of releases ago, all the usings go away. With the primary constructors, all those temp variables go away. It just makes the language feel so more clean is what I would say.
Mm-hmm.
And as a developer, I want to focus on my code, not just repetitive
Syntax.
goop is what I would say. That's the proper word for that. But it's a shame we don't have video. I would actually show this in real use. But that's a C#. So that's kind of item number one. I think item number two, it's not super critical, but I think it's interesting. And so if you look at .NET over the years,
mm-hmm.
when we started doing that reboot of .NET, well, we thought like, hey, cross-platform matters, open source matters, and then performance became a big component of the platform. Why would you choose .NET over all these other languages? Because there's, as a developer, we have lots of choices.
Mm-hmm.
And so, we did the performance work saying, hey, if you build a .NET app, it's going to be faster than a Python app. It's going to be faster than a Node.js app. It's going to be faster than a Go app or a Rust app. And then kind of along the way, with the language, we said, hey, we're going to make it, writing an API should just be as simple as writing an API in Python or an API in Express, and a bunch of language features happen. And I don't like the term, but we had, minimal API, if you want to say that. That's you can just basically start your application, write some calls to say map this URL to this code.
Yeah.
Change compared to the ASP.NET that you and I grew up in. But so we're always looking at how do we compare against something else. And so over the last couple of years, there's been an increase in popularity of things like Go and Rust. And some of the magic that both of those languages have is when you compile an app, it actually turns that application into a native app.
Mm-hmm.
And so what I mean by that is I don't have to have Go or Rust on the machine. I get an exe. That exe works. I can just give you the exe and it would work on your machine. So that's the self-contained app. And we've been taking it over time across all the .NET Core and .NET releases. We've been making strides in that space. So we introduced a couple of years ago a self-contained application. That's where we go and take all the DLLs that are required for your application. We shove them into a single exe, and you don't require .NET to be on the machine. We've added trimming to that as well, where we actually can remove the stuff that your app doesn't actually use. We shrink that size down, and we got ourselves down to, I think, about 20, 21, somewhere in the 20 meg range on the last release of .NET. But we've never really done what I would call AOT. And AOT stands for ahead of time compile. And so, and for most of our .NET customers, I don't think AOT matters, but we are seeing popularity in those languages. And so we want to make sure that .NET is great in that AOT space. And so what this means is, .NET today, just to go full back, we don't actually produce machine code.
Right.
We produce what's called IL. And then when the application boots up, a just-in-time compiler goes and converts that IL into native code. The benefit of that technology, it means we don't actually know when you write the app, you don't know if it's x64 or x86. The jitter comes up and will produce the right code based on the platform that you're running on.
Mm-hmm.
But because that jitter boots up, it means the app's going to start a little bit slower because we're actually producing that native code. It means the app's going to use a little bit more memory because we have to have room for that jitter to be part of the application and to go produce that code. But we have heard from some customers that it's actually important to have a really fast super startup app, to have an app that actually doesn't require a ton of memory.
Mm-hmm.
And so I'm going to grab my laptop and I just want to bring the numbers up. I want to try to guess them out of my memory. And so in .NET 8, which we just shipped, there is a new template in Visual Studio called ASP.NET Core Web API, parentheses, native AOT.
Mm-hmm.
And so for the first time ever, we've been able to go take, some of the traditional web kind of stuff that you would build, and we've been able to make that actually work with AOT. And let me explain why that's a challenge. A lot of things that .NET does, we use reflection, where we can go and look at stuff, and then we can actually also produce code on the fly as well using reflection. that doesn't convert to AOT very well.
Right.
And so we've been on this journey to slowly go through and update a few of these things. And every release we'll go a step further. We've got APIs working this time. Maybe the next time we have MVC working. But here is an example of, read some numbers to you. Okay. So if I build a .NET web API today and I publish it, I can do that single exe kind of thing that I was telling you before. That's going to produce a 95 meg exe.
Mm-hmm.
When it boots up, it's going to use about 87 megs of RAM.
Okay.
The startup time is going to be about 142 milliseconds, and it's going to do 809,000 requests a second. And it's, we've got great performance. So if I take that same app and I AOT it in .NET 8, the published size of the app is under 10 megs.
Nice.
So that's
yeah.
95 megs to under 10 megs.
Mm-hmm.
The working set, which was 87 megs, is now 40 megs. That means it runs in 40 megs of memory or less.
Mm-hmm.
The startup time goes from 142 milliseconds to 34 milliseconds. Because you don't have to boot up in JIT.
Yeah.
And then our request per seconds, this is where people that are listening are going to go, what? The request per seconds today is 809,000 requests a second. It's going to drop to about 724. So not a big drop, but a little drop. And so this also means if you want to build like a command line tool in .NET, you can build a under 10 meg. Like I think Hello World is just like 2 megs now. And so if you build a command line tool and you want to ship that to people just to install on their machines, those become super small. That's kind of the Go and Rust kind of thing. Mm-hmm. The reason that RPS dropped is that Jitter's amazing tech. The tech is so good today that the Jitter might go, hey, I jitted something and the app is running, but it's like, wow, that code's being called a lot. Let me jit it again and make it even faster.
Right.
Or the Jitter might be able to say, hey, I can actually see the path through the code. And because of that, I can actually optimize the path that the code's using the most. And so the Jitter's always going to be a little faster than ahead of time, because ahead of time doesn't know how the app's actually running. We compiled it, and the app can never change again. It's immutable, and so it can't adjust or be changed on the fly for performance. But you get almost the same performance, great startup. And there's, as I said, I don't think this is going to change the world, but it means that somebody can't come to us and say, well, my Go app is smaller or faster than a .NET application.
Yeah.
To me, it's like our job is to make sure that the .NET is best of breed in all these different places. And it's amazing tech. I can build a desktop app on Windows. I can build mobile apps on iOS and Android. They run on Mac and Windows as well. I can build great web applications. I can build great APIs. I can build great command line tools. We've tried to make .NET work in all those places, and this ahead of time compile thing is just another piece of the journey. And it's actually building on the tech that we built for Blazor for WebAssembly, which is AOT'd, and also those native apps. Being able to run a MAUI app on an iOS device, that's also AOT'd. So we're taking that AOT tech and making it available in more places. But it's exciting to me that we're doing that. One of our principles is not changing the way that .NET works. Java has a feature called Graal VM, which is how you would write native code in Java. But much of the Java ecosystem doesn't work in Graal. And so one of our design goals as we think about ahead of time compile in .NET is how do we make it work without breaking the entire ecosystem? Yeah. We don't want you to change your app. As I said, I'll be very clear. You can't run it with MVC today, but that's because routing is using reflection. We're using dependency injection as well. And so, but we can make those features work in AOT. It just takes us more time. And so I think every .NET release, the AOT thing is going to get a little bit better. But we've taken a huge step. This is the first time you can run web in AOT in .NET, in .NET 8. Yeah.
Well, I'm thinking of how common are the scenarios where you need a really small program to run inside an Azure function, or an Azure container app, or just a really small little program that sits there behind the scenes. And there's two scenarios. Either it has a couple of web endpoints and it's an integration with something else inside Azure, or it sits there and it just listens to an Azure Service Bus queue. And when messages come, it just moves some data or does something. And so it's not a whole lot of code, but we want to be able to use the bursting. We want to make it really cheap to run and just be able to burst with volume, but with really jagged usage curve.
It excites me because as part of this journey, we've been, I've been working on .NET since 2007, and so I just love seeing this progression, and we're gaining these new things over time.
This is the first version.
The cloud native stuff, I do want to drop one more thing and think about that I like, and that is we also artificial intelligence, AI, OpenAI, whatever that you want to think about.
Yeah,
I'm excited about that tech as well. And Stephen Tobe has a great blog post. I assume you can share blog posts with the podcast. So we'll
put it in the show notes.
And so as I've been on the speaker circuit and talking about .NET recently, we have a library called Semantic Kernel, and it's a preview library today. The reason it exists is because, and if you're in the Python world, there's a technology called LangChain, and this is for doing large language model work. We obviously don't want a .NET customer to have to be using Python as part of their job. We want you to stay in .NET. And so two things that are interesting. Number one is my team has built or ported the OpenAI SDK to .NET. And so we have the OpenAI SDKs are all available in .NET. We've got the Semantic Kernel for doing large language models. And here's the blog post. Let me just, I'll paste it in the chat so you can put it in.
We'll do it.
The notes for the podcast.
And for the listeners out there, this generation of AI is so new. We're specifically talking about the generative pre-trained transformer, or GPT genre of AI, right?
Yes.
I think all the listeners probably by now have definitely used ChatGPT, have used chat.bing.com, have probably used Google Bard, and have been using even Zoom and Grammarly. I mean, it's being embedded in so many different products, all the Copilot generation of tools that are out there.
Yes.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
We're in the AI moment, which means we'll have way too much AI for the next year. And then slowly over time, it'll par down and we'll have, we'll figure out what the right things are that we have.
Now, you said the OpenAI SDK in .NET. So what are the scenarios that are kind of being targeted with that work?
Yeah, so let's talk about that. So Steven's got this great blog post. I'll put a link in so you can share that in the notes for the podcast. And I'll ask you: are you aware you can write ChatGPT in 6 lines of .NET?
Yes, because I kind of went through one of the samples, but that's just embedding it into your own webpage.
Most people would be surprised that you can actually write a ChatGPT experience in just a couple lines of .NET code.
Yeah.
Makes me super excited. So, but Semantic Kernel is the .NET equivalent of LangChain, and a combo of Semantic Kernel plus the Azure OpenAI stuff gives you a pretty great developer experience. The blog post walks you through a couple scenarios that I think are pretty cool. You start off with a simple chat,
Mm-hmm.
and then I can ask that chat, well, what time is it? And the chat's going to go, well, for folks that don't know, ChatGPT is based on it's a model built on the internet. And so it's frozen in time. It doesn't know things like current time. But I can go and add a little bit of code and say, oh, let me teach ChatGPT by writing some .NET code. Call this code if somebody asks a question about the current time. And the code goes and runs the .NET date time now command to produce the current time. And then I can start asking the chat about the current time.
Yeah.
So that's a couple, which is kind of cool. Then the next thing is, well, I might ask the chat to tell me a joke about something. And then I ask, well, why is that funny? And the chat goes, well, I don't know why that's funny because I don't know what you're talking about because it doesn't know any of the history.
Yep.
Another 2 or 3 lines of code. And now you're storing both what I type in and what response is coming back into a buffer. And so that lets the AI kind of know the history of what you're talking about. This is how, if you're actually using ChatGPT, that's how it actually works. And so that's great. And then I ask it something about something that was not produced in that model. I'm like, well, tell me about the performance improvements in .NET 8. Well, that blog post was written after, the GPT-4 model was
September
created.
of 21.
And so the next thing is, well, I'll just take the blog post and I'll shove the blog post directly into the chat buffer. And then the code's going to crash. And it's going to go, you gave me too much text. I don't know what to deal with that. Then the semantic kernel gives you a mechanism to do that as where I can chunk data into it. And what happens is, based on the question I ask, some algorithms will happen. And instead of giving it the entire blog post, it'll just grab the blog post that's most relevant. It'll shove that in the chat buffer. And now I can ask those questions about, the performance improvements in .NET 8. And then the final step of that is that the chunking of that stuff and putting it into a buffer is expensive. So I really want to use a vector database for that. But I have a sample that I will give you a URL for as well, Jeffrey, that walks you through this progression. It's a command line tech where you can actually walk through this progression from start to finish. And so I'm just super excited that, we shipped ML.NET a couple of years ago in .NET, and that's really for classic machine learning. That's for somebody that understands algorithms and training. And I feel for the first time ever that I was able to write useful applications in a couple lines of code without being a machine learning expert. And so that's what excites me about this wave. And I'm excited about Semantic Kernel. I'm excited about the OpenAI SDKs, and that we've made this available to all .NET customers. And so once again, we want to make sure that as a .NET customer, you always have access to the latest bleeding edge tech. So that's 3. And I've got one final one, which is I think the biggest one.
Still in AI or different?
No, we're going to go to cloud native now.
I've got a question just on the OpenAI SDK.
Yeah.
How close is that to being able to take tables in my own application's SQL server and pump it in so that I could like if it's a junior livestock auction, I could then just say, hey, tell me about the pigs that sold in this auction. I've got it in my database. How close do you think we are to that type of scenario?
We are pretty close. Unfortunately, today you'd have to write a little bit of code. You'd have to write code to basically extract the data from the database. You'd have to then pump that data into another database, a vector database. But it's not a lot of .NET code to go write the code that can say, hey, have these tables changed? Hey, for example, you can use triggers inside of SQL Server, for example, to let you know that tables have changed and stuff like that. And then you would rerun the processor. In most cases, one of the demos that Brady Gaster shipped at .NET Conf was a demo he calls Ragger. And that's one where it's not real time like what you're describing. But what you can do is you can go and upload a PDF. It's got a part of the web app. And I'll give you a link to the Ragger demo as well. You can put that in the podcast notes as well. In his case, you can basically take a PDF or a document and upload it. And then behind the scenes, he's got a job that runs in the background and processes that, does all the indexing, puts it into a vector database, and then it'll tell you when you can actually search on that. You just have to write that little logic code to go and say, hey, I noticed there was a change in the data. Go run a background job to go, put that into the vector database, and then you can query against that information. So that's
nice.
As I said, that's why I'm excited. It's not a huge leap. It's not let me go read a 300-page book on how to do AI. It literally is. I need some logic to go see if my database has changed recently, and if it does, I run this code to go do that. So
very cool.
Yeah.
All right, next item.
Let's talk about Aspire.
.NET Aspire.
.NET Aspire. So .NET, ASP.NET Core has always been a web framework that you can build anything with. You can build cloud native with ASP.NET Core and .NET 7. You can build anything. We've always had the ability to build anything, but we've kind of left it to the reader or the writer to go and figure out their path to go do these things. And so the idea behind Aspire is to give our developers what we would call a cloud native web framework. And we're not rewriting ASP.NET. It literally is, you're going to use the same web APIs. You're going to use the same Razor pages, MVC pages, Blazor pages that you've done before. But let me explain what makes it special. So what are the problems you have when I say cloud native? The first thing that comes to my mind is I've got a Blazor front end and I've got a web API back end. And I know I've seen some of the apps you've written, Jeffrey, so I know you're really good at this. But how do you develop that? Well, what you do is you create your Blazor app, you create your web API app, and then you go into each of them and you go find the startup, the launch settings, and you paste the IP address of one into the other, which is a very fragile barrier. So to make the Blazor app be able to find the backend app, you have to go find what the launch setting says is the IP address of the backend app and paste it into the Blazor app, and vice versa if you wanted to call both ways. If you publish that to the cloud, well, those local machine IP addresses are going to change again. So what we find is it's very cumbersome. It's even hard in many cases to actually make something I can give to you and it just works, because you might have a port conflict in your machine. And so Aspire tries to solve that. It's going to go solve the connection problem. With Aspire, I can basically give the apps a name. The front end app, we can call it front end. The back end could be called back end. And when the Blazor app wants to make a call to back end, it just says back end. The URL is just back end. And we do all the IP address and port mapping stuff behind the scenes for you, which means local development is very easy. And then when you move it to the cloud, we do that for you. And so I think that's a huge step. Another part of Aspire that's very interesting to me is, anytime you build an app that's multi-part, Visual Studio has been around for a long time. The tools inside of Visual Studio to run more than one project at the same time.
You're on your own.
Haven't really changed in like 15 years. I mean, they've been there for a long time, but they've not gotten any better. And so folks that don't know this, what you do is you right click on your solution and you can click and say, well, here's my startup project. And you can choose which projects to start. You can choose the order for them to start. And then it's kind of clumsy and clunky. It's slow to start. It's just, I don't consider it to be a great experience. And it gets really bad when you go to VS Code. Well, VS Code doesn't have that feature. And so in VS Code, what you're likely to do is actually have a terminal with 2 prompts in it, and you manually run the applications in each of the prompts. Or you can go to VS Code and you can have 2 VS Codes, and one for the back end, one for the front end. You can start each of those and make sure you start them in the right order. And we just haven't had a good solution for this. And Aspire brings, it's not an Aspire technology necessarily, but there's a thing called DCP. And it's basically a tech that knows how to run multiple projects at the same time. And so our hope is to give you the experience, whether you're in Visual Studio or VS Code, go run all the parts of my application in a seamless way. And so Aspire does that for you as well. The next thing that Aspire does that's super important is, when I'm building an app on my local machine, well, the database is on my machine. Maybe I'm going to use a container. Let's not go to container. The database is on my local machine. the front end, the back end are on my local machine, it's going to work every time because, well, it's all on my machine.
Even
when you
SQL
move to the
Express
cloud,
or whatnot, it's easy.
well, your database is somewhere in the data center. Your front end is somewhere else in the data center.
Yep.
And in a perfect world, I mean, in your office, you have an Ethernet cable between the front end machine and the SQL server, and it's going to be fast every single time.
Mm-hmm.
In the cloud, well, there's lots of crud going on, and sometimes there might be a delay for whatever reason. Data centers are huge, big devices, and so you should always be using for your databases. You should be using retry policies. For your HTTP clients, you should be doing retry policies.
Mm-hmm.
We've offered these capabilities for a long, long time. Like for HTTP client, I think we added that stuff in 3.1. For the database, I think we offered that even before that.
Just built into Entity
Aspire's
Framework.
going to turn those things on for you by default.
Nice.
And so the best practices, we're going to say, hey, HTTP clients should be doing retry policies and backoff policies, which means when there's I'll call it a burp, occurs in the cloud, your app doesn't fail right away. It actually tries again and just doesn't assume failure the first time. So we're making your app more resilient. The next piece of Aspire, which is super cool, is what if I want a Redis cache or a Postgres database? Well, then you have to tell all your developers, go install this on your local machine. I hate installing stuff on my local machine. I want my machine to be as free of stuff that I don't need temporarily.
Yeah.
If you gave me a project, if I clone Jeffrey's repo and it said, oh, go install Postgres, like when I'm done, I need to go uninstall Postgres. And so there's another feature in Aspire where we let you actually add components. So you'll be able to go to the Aspire tooling and say, I want to add an Aspire component. And so in this case, I might want to add a Redis cache. And so what we'll do is we'll say, we'll bring in the library, the best library for talking to a Redis cache for you automatically. We will put into, and we'll talk about this last, we'll put the hook in so the front end and the back end know that there needs to be a Redis cache there. And when you run locally, we'll go and download a Redis cache in a container, run it inside the container. And when you stop running the application, the container goes away. And so no longer do I have to worry about installing that Postgres, that MySQL, that Redis cache, or whatever the technology it is. Now that thing runs in a Docker container. And when I'm done, all the tech is off my machine and I feel like nothing's bad happened to my machine. I can give you a great Control F5 experience on your own box. And when we move you to the cloud, we would probably move you off of using your local copy of that and use something like Azure Redis Cache to do that. And so that's kind of an umbrella of a bunch of the big things that Aspire tries to do for you. And so the way that works is, today you would have your Blazor app and you would have your Web API app, and they'd be kind of in their own isolated forms. There's now a third app that gets created, and I call it the orchestrator app. I don't know what the .NET team calls it, but for me, it's the orchestrator. And that's the app where I say, hey, I've got a front end, and I'm going to call it front end. I've got a back end, and I'm going to call it back end. And each of those lines, I then specify which project in my solution, which class makes up those things. And then I can tell the front end that it depends on back end. Well, why does that matter? Well, that matters so we start things up in the right order. So when the front end boots up, we've already booted the back end up. It also, I could say that the front end depends on the Redis cache. That will cause us to pull the Redis cache, boot the Redis cache up. And so all of that stuff, by having that glue project, it kind of tells the tech, how does everything hook together? That's what actually powers Aspire. And that's also what powers that startup process I said before. DCP can look at that host project and go, oh, I know how to go boot all this stuff up for you. But it gets even better. And so the final piece of this, and I'm still losing, there's a million things I'm not going to talk about, but the final piece is when the app runs, we don't run the app, we run a dashboard. And the dashboard is kind of the dashboard for that orchestrator app.
Mm-hmm.
And so in our scenario, we've got a Blazor front end, we've got a web API back end, we have a Redis cache. I go to the dashboard, I'll see both of my projects. I can click a link. Each of the projects will have a link for the URL that will launch that project. I can launch the back end and see the API return results. I can launch the Blazor app and see the results of that. From that same interface, I can actually go and look at the logs and see how they started up, what was written to the console.
Mm-hmm.
There's a container tab. I can go to the container tab that my Redis cache is going to live there, and I can see that it's booted up. But it gets even crazier to me where we have this, once again, best practices. So
yeah,
when you build your ASP.NET Core applications, do you remember to turn distributed logging on? Do you turn all the right logging stuff on? The answer is we've had all this tech for a while. We don't turn it on by default. And so Aspire applications have all the best logging practices turned on by default, which means, imagine my scenario, my Blazor front end calls to the web API. I can see that entire transaction in the distributed tracing inside of the dashboard. It'll show me that the front end ran.
Mm-hmm.
It called the back end. It'll show me how long each of those processes took. And when I add that Redis cache in, the next time through, it'll show that the web front end didn't call the back end. And if I click details in the trace log, you'll see that the response came from the Redis cache. And so it feels like in 2023, we've taken all of this tech we've built in the last decade, from 2013 to 2023,
mm-hmm.
and we finally glued it all together in the way that you would actually really build a multi-part application with startup, control F5, all the connection mechanisms on how the things can see each other and talk to each other, and including having the best logging practices, the retry policies,
Mm-hmm.
just every best practice of .NET kind of built in. And the final one piece of that is super cool is the build output of an Aspire project also writes down what we call a manifest.
Okay.
And why do we need a manifest? Well, running locally is great, but if I want to run this thing in the cloud, my cloud tools don't know what just a jumble of applications are. But the manifest is a tool that a cloud tool can use to go figure out how to help you publish that app to the cloud. And
Mm-hmm.
so my team builds what we call the Azure Developer CLI.
Yep.
It's got a new capability where you can point it at the Aspire manifest, and then it will say, oh, you want me to build a container app in Azure for that? Do you want me to build a Redis cache for that? Do you want me to build a Postgres in Azure for that? And it'll go build all those assets in Azure for me, and then it will publish the entire application to Azure for me. And so I could sit here, you and I could work on a project together, and then run AZD up on your machine or my machine, and the whole thing would go to the cloud. And so that is as I said, it's a public preview.
Mm-hmm.
With .NET 8, it'll ship sometime likely next year. But it feels to me it's like of all the web tech we built over the last couple of years, it feels like it's all come together into a single project for building these multi-part cloud applications. So you can tell I'm excited. I hope.
Well, for sure. Well, and I think it's good timing because for the longest time, we built monolithic applications where we had a UI. Way too much code was in the UI and then a database. And of course, a lot of people said, hey, that's stupid. We need to build microservices and we need to split this up into 10 or 100 different Git repositories. Well, really, for probably the 80-20 rule, or most applications, a distributed application architecture would be perfect for it, where it's still one Git repository, still even one Visual Studio solution, but now we have multiple deployable programs within that Visual Studio solution. And yeah, they just have to be stitched together. They have to have some configuration on deployment. We need a good developer workstation loop where I can hit Control F5 and run all of the, let's say 8 different programs they have to spin up and be stitched together so that they know where each other is, so that when I click a button, it does what it needs to do. I think it's perfect timing.
Yes, I the analogy I would say is, like you're a Java developer, you've had the Spring application forever, and it feels like we're bringing that same thing to .NET. So, and I think people are going to love it. I cannot wait to see the reactions. I mean, this thing just shipped, but I cannot wait to see the feedback. I know you. I think you saw an early preview of it yourself. So
the feedback is already coming in. Everybody's really excited about it already, and just in the preview bits that are on GitHub, and they for the scenarios that are already out there, it works. They're just with the preview. There needs to be more scenarios and more dependencies to come online. So
yes,
I love it. Well, like you said, we could go on for a long time to come. There's so much packed into this, but man, thanks so much for coming back on the podcast and sharing with us what's kind of the highlights of .NET 8.
You're welcome. I will say the one thing that we really skipped over is we skipped over Blazor, and you really should. I'm happy to set you up with Dan Roth.
Actually, I think next week or the week after, his podcast comes out on .NET 8 Blazor.
Perfect.
Yep,
that makes me so happy that Blazor is we're at a place where we're kind of merging, and you can actually use MVC, Razor Pages, Blazor all together in the same application, which is so go see that Dan Roth podcast, because that's going to be it's kind of like feels like ASP.NET's coming back together as well. So that's exciting too.
Yeah, it'll 2 more weeks, listeners, and we'll have Dan Roth back on the podcast with all the Blazor things for the .NET 8 era. So, well, Scott, hey, thanks again, and appreciate it. We'll have to do a mid-cycle episode just to really touch on all the amazing advancements in just the .NET space.
Yes, there's so much. That's why it's we always say it's a great time to be a .NET developer. I say it every year. It feels like every year there's another step that we take, and so
right, for sure.
Yes, let's not wait a year this time.
Good plan. All right, listeners, and until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.